Okay. So, quotient rule is going to need to be used anytime you're trying to take the derivative of a fraction that has x's in top and bottom. Okay. So, there's some similarities between the quotient rule and the product rule, but there's also some differences, obviously, and the quotient rule is a little bit more extensive. All right. So, for the quotient rule, f is your top function, g is your bottom function. So the order matters for these because you have a minus sign in between, right? So with product rule, we did f times g prime plus g times f prime. But we could have done g times f prime plus f times g prime, right? We could switch the order because it didn't matter because we had a plus sign in between them. But these you cannot. So you have to have g of x, which is your bottom function, times the derivative of your top function minus the top function times the derivative of the bottom. And then it will be all over g of x squared, the bottom squared. So there is a saying, well, kind of a saying, I guess, that we use to kind of help us remember this. If we're taking the derivative, instead of thinking f and g, we could call the top function the high function and the bottom function the low function. So a lot of teachers use this to help kids remember the quotient rule. It is low d high minus high d low over low low, or low squared. So, low, d high means derivative of the high, derivative of the top, minus high d low, high function, top function, minus derivative of the bottom function, derivative of low, all over low squared. So, in order to help you remember, and for your listening pleasure, Austin Coley and Trevor Nance would like for you to listen to this song that they created to help you remember.
Talking about that quotient rule. You already know.
I think that's Silas Coley that's making the
I walk into class,
noises.
open up my book, make sure that I pass. Derivative, that's what we working on. Working on my homework from dusk till dawn. One day in Calc said she got a little.
I think that's me. They call me young Cal.
You know I want to
I mean, not
hear
every
it.
day, but
She
it's
said the quotient rule is gonna help you out a lot. I said, what's that? She said, boy, let me tell you what. Low D high. Low D high is high D low. High D low is where the bottom. Where the bottom, how we roll. Low D high. Low D high is high D low. High D low. It's the quotient rule, man. You already know. On the mic, you know who it is. I know the quotient rule won't help me ace and quiz. Get money, getting cash, yeah, you know the biz. Now watch me count all this money while I talk to fingertips. It's the chef game, yeah, you know we cool. Getting all the babes with that quotient rule. You know we try, play with baby. Taking the river till the ball is running, that I'm like, yeah, boy. Yeah, you know chef game about to be swimming in that crazy, about to be surrounded, baby. Yeah, you know it. Mixtape, cooking coming soon, baby. Low D high. Minus high D low. Square the top.
wish they'd made a video. So, I might can email that to you guys if you wanna put that on your playlist. Whenever that, gosh, it's been a while. I think that was probably 2016 because I think the first year I taught AP Calc was 15, and I think they were in my second group. Does that sound right? Frost and Foley, I think. And so Hunter was only in like first grade or something, and he wanted to listen to it all the time. Like, we would listen to it in the car going to school. He loved it. But I mean, high production quality. So I will offer you this extra credit as well. This was extra credit for them. This is a one-time offer. I've had to restrict this because, oh gosh, who was it? Somebody was basically going to, like, cut a whole album on calculus songs. I had to restrict it. So, a one-time offer available anytime, up to 10 points on a test. But it needs, like, I mean, this obviously got them both 10 points because it was very, very high production quality here. They did a really good job on that, and it was creative and pretty catchy. So, so up to 10 points on your lowest test. This is available anytime, but you can only do it once. So you can't. You also may collaborate, but to get the full 10 points, it's got to be like equal collaboration and like good quality. You can't be like roses are red, violets are blue. I like derivatives, don't you too, or something like that. It's not going to get you much, But it can be for anything. Like quotient rules was great to do it for, but any of the rules that we do, like some good ones I haven't had people do. I don't think. Maybe somebody did a chain. I don't think I've ever had anybody do like a chain rule one, which we hadn't gotten there yet. But I feel like chain rule, just like the name of it, sounds like it needs a rap song for it. But chain rule is one I don't have a great one for. Really, this one's the only one that's been like so good. I want everybody to listen to it every year. I've had some decent ones. It'd be good to have one to help you remember all the trig derivatives because they can be a little tricky, which we haven't done all of them yet either. But this is open to you guys as well to get extra credit if you would like. If your dignity, I mean, this is good. They should be proud of their work here. Some of them maybe have not been all that good, but if you don't mind embarrassing yourself a little bit, it does not have to be a rap song. It could be of any genre of music that you would like. If you want to, like do a video or something, you could. I've had a video or two for that, but this is available to you if you so desire. There. So, all right. Okay, so let's look at what we've got to do for quotient rule. The quotient rule itself, executing it is not terrible. Simplifying once you take the quotient rule is what's difficult about these problems. So, for example 1 here, we, of course, are going to let this top function be our f of x and the bottom be our g of x. So, when we do the quotient rule here, our derivative is going to be low, so the bottom, x squared plus 2x, d high, so derivative of the top, and that would just be 3 in this case, minus high, make sure you put in parentheses around this when you write this in. 3x minus 4 times derivative of the bottom, derivative of the low. So that would be 2x plus 2. All over low squared. So x squared plus 2x. So just to make sure we know where everything's coming from here, this was our low, our bottom, times the derivative of our top, f prime. Then our top times the derivative of the bottom all over the bottom squared, so g squared. Low, d high minus high, d low over low, low, low squared. There. So this, at this point, you have taken the derivative. You are, if all it says is take the derivative, you're done with taking the derivative. But rarely are you ever going to see these where you don't have to simplify. Most of the time, just a straight question like this is going to be on multiple choice. You're going to have to simplify it. So to simplify, we would need to distribute here. And that is going to give us 3x squared plus 6x. Here, you need to be very careful. We need to multiply these two together, but we also have that minus sign right there that's going to have to be distributed to everything. So I would leave the minus and do all this stuff first. So you're going to get 6x squared, and then you'll get plus 6x minus 8x, which is going to give you a negative 2x for that middle term, minus 8. And, oh wait, I didn't put the square right there. Don't multiply the denominator out. Sometimes there might be something that will factor, so you do not want to multiply that denominator back together in most cases. Okay, here. All right, and then we're going to have 3x squared plus 6x minus 6x squared plus 2x plus 8 over x squared plus 2x squared. So that will give us negative 3x squared plus 8x plus 8 over x squared plus 2x squared. And I wonder, I don't know if anything will factor there. That'll cancel anyway. I think this is probably it. Let me show you something they will probably do in the denominator here. X squared plus 2x, what can we pull out of that? We can pull out of x. If you pull out of x, though, this is how it works. You're pulling out of x, but it is still inside of the parentheses that square it. So that means that denominator would be x squared times x plus 2 squared. Because the square applies to everything on the inside here. So if you pull an x out, it is still being squared. So you would have to square both things here. So they might simplify it like this. Let's just make sure this won't factor. So I'm going to factor out negative 1. So 3x squared plus 8. I'm sorry, minus 8x. Minus 8. for anything to cancel, you'd have to have a plus 2 right there, which means you have to have a minus 4 here, which does not give you that. So I don't think anything's going to cancel that would, if it will factor, it's not going to help. So you just leave this negative 3x squared plus 8x plus 8 here. Now, it's not required that you do this here. It's just that multiple choice answers, you might see it look like that instead of like this. Okay. Questions? All right, let's do another one. All right, so we got 3 minus 1 over x plus 5. So everybody's favorite, complex fractions. You have several options of how to deal with this. You probably do not want to just try to take the derivative of it as it stands right now. You either want to get rid of that complex fraction before you take the derivative, or you could change this 1 over x to an x to the negative 1 power, right? Use a negative exponent there. So really either is fine. I think I would rather not deal with negative exponents. So what I'm going to do here is I'm going to get rid of the complex fraction. So one way that we can do that, one way you can do it is to get common denominators in the top and flip and multiply. Whenever you just have a single denominator like this, I prefer the method of just multiplying the top by x and the bottom by x. Because here you will distribute. This is still f of x. We're not taking the derivative right now. We're just simplifying so we can take the derivative more easily. And we would get 3x. And then what do we get when I multiply x times 1 over x? X's cancel, we just get a 1, which is what we want to happen so that we don't have a complex fraction. In the denominator, we'd have x squared plus 5x. Everybody okay here? All right, so now we are going to take the derivative. And so low, so x squared plus 5x, d high, Zach, what's the derivative of that numerator there? 3, minus high, which is 3x minus 1. Connor, what's the derivative of the denominator there? 2x plus 5, all over low squared. And so simplifying this is going to be similar to the last one. I want you guys to try to simplify it on your own. I'm going to cut the screen off as I do it so that you guys can try that on your own. most of you are about done there. All right. Here is what I got. This numerator would factor, so I did factor it just to see if anything would cancel with the denominator. It does not, so there's not like an advantage to factoring here. So either one of these is fine. But every once in a while it will cancel, so you might want to check for that. There, so this would be our derivative here. Okay. Question. They would not, because if you did a love connection, you would have to divide like everything by x squared times that. So like if I were going to do love connection, I'd have to have like negative 3x squared over x squared times x plus 5 squared. So you can't do love connection with just like one. Well, I mean, especially in this case, like if I wanted to do love connection with an x squared, I guess you could do that, but you'd end up with negative exponents in your numerator. Yeah, where you'd get that 5 over x, and it'd be a complex fraction again. I don't think you'd ever see them do that. So, in general, it's pretty much going to be left like this. I'm not going to say never, but almost never is it beneficial to multiply that denominator, like expand that denominator. And you typically want to see it factored. Okay. All right. So here's a warning to you. They're going to do this to you on your homework as well. You do not have to use the quotient rule for every division problem. For example, this problem right here does not require the quotient rule. You can do it with the quotient rule, but you don't have to do it with the quotient rule. Because what could you do for this problem? Yes, you could factor out an x. It would still give you an x in the bottom if you did that. So what I would just do straight away, because you're going to have to do this either way, is do the love connection. Here, divide both of those terms by that x squared. So if you do that, then you're going to get f of x equals, you're getting x to the third over x squared minus 4x over x squared. That would be just x to the first power minus 4 over x. And we'd write that x minus 4x to the negative 1. Which factoring out the x essentially does the same thing, but you're going to do the love connection like the next step after that too. So this is just a little faster. So this is still f of x. You have not taken the derivative. What is the derivative of x? Is 1. Here, just use power rule. We get plus 4x to the negative 2. There. They will probably send that x squared back down to the denominator. They might even get common denominators here. So they might multiply by x squared on top and bottom. And so f prime of x would equal x squared plus 4 over x squared. You might see it like that. Now, any of these last three are fine. It just depends on what your answers look like, which one you would choose. So there's going to be, I know there's at least one on the homework, there might be more, where you don't actually have to use quotient rule. You can use quotient rule. It's just going to take a little longer and cause you to have to like do more simplification if you do that. So watch out for these. You don't necessarily have to use quotient rule on all those. All right, here's one with some trig. So if we take our derivative here, okay, low, which would be sine x, times derivative of the high. Derivative of 1 is just 0. Derivative of negative cosine x is going to be, derivative of cosine x is negative sine x. But then when we put this negative out here, it's going to be a positive sine x. Minus high, 1 minus cosine x, times the derivative of the low. What's the derivative of sine x? Cosine x. Over sine of x squared, which we can write as sine squared x. So if we simplify this sum, we're going to get sine squared x minus, I'm going to put the bracket here because that negative still got to be distributed, cosine x minus cosine squared x over sine squared x and then if I distribute this negative, I've got sine squared x minus cosine x plus cosine squared x over sine squared x. Alright, there's some simplification that can happen here. Quite a bit, actually. Anybody see something that we can do? Perhaps some trig identities, everyone's favorite. What was the Pythagorean identity? Sine squared x plus cosine squared x equals 1. Look what we've got right here. We got a sine squared x and a plus cosine squared x. Can we rewrite that? So it would be, I mean, this is not necessarily a step you've got to show, but sine squared x plus cosine squared x minus cosine x. And then, if we do that, this stuff right here is just equal to 1. So we would have 1 minus cosine x over sine squared x. Alright, there's more. What can we do? It does not. Say that again. It does not. 1 minus cosine x does not equal sine x. But 1 minus cosine squared x does equal sine squared x. So it has to have the square for that to be true. So we cannot replace the numerator, but we could replace the denominator with 1 minus cosine squared x. So 1 minus cosine x over 1 minus cosine squared x. Okay? What now? Alright, the numerator's just going to stay the same. I cannot cancel. It seems like I should be able to like cancel one of those cosines with one on the bottom. I cannot. But if I factor the denominator into 1 minus cosine x, 1 plus cosine x, which I can do because it's a difference of squares, now I've got multiplication between these terms. I can cancel f prime of x is going to be 1 over 1 plus cosine x. Oh, that was fun. Now, we took the derivative way back here. This step, we had f prime of x, right? We had the derivative here. This is the derivative. There might be instances where you could get by with dealing with the derivative from right there, right? You don't, you're not going to see a problem like this probably, but if it was FRQ and it said take the derivative and that's all you had to do with it, you could stop there. You have taken the derivative at that point. For most students, I find that's not like the part we have trouble with. We're okay here. It's all of this simplification that is really not calculus at all. It's all, just basically advanced algebra tricks, stuff that you're doing here that gets you all the way down to here that is the difficult part of this. So, but these typically show up either on multiple choice where you've got to be able to simplify them, or they ask you to do another step with them later that's going to cause you to have to at least simplify some, at least get it down to, this or something. But, so you'll see some of this. All right, questions? All right, so homework is going to be to do 7 through 12 and 29 through 36. I will let you skip 2 problems. Okay? So, of those, if you run into a couple that you don't want to do, you may skip 2. Alright, we got a little while to get started on that, so that is good. On your odd problems, do try to get your answer to match the back of the book. On the even problems, obviously, you don't have that, so any way that you leave it is fine on those. I'll tell you what, the simplifying can get a little lengthy on this. I don't want you to have 2 hours of homework. I'm going to let you skip 4. Okay, I'll let you pick the 4, though. me if you have questions, but I'm going to try to grade your effort. Set it off. Not done yet. So ask each other questions. Bring it up here if you guys have questions. I'm going to try to